Hi friends, I hope you enjoy the previous lecture, which is the first part of Nmap Complete course. If you didn't watch first part, make sure watch that first. Let's get started with TCP and FTP bounce scan. This is used to bypass firewalls, because organizational FTP servers are often placed where they have more access to other internal hosts. This enables a user to request that files to be delivered to a third-party server after connecting to one FTP server. Most servers no longer offer this feature because it is vulnerable to misuse on many levels. The FTP server port scanning other hosts is one of the misuses that this capability permits. Simply ask the FTP server to send a file to each interesting port of a target host in turn. The error message will describe whether the port is open or not. Nmap supports FTP bounce scan with -B option. If bypassing a firewall is your goal, scan the target network for open port 21 or even for any FTP services. If you scan all ports with version detection, then try a bounce scan using each. Nmap will tell you whether the host is vulnerable or not. If you are just trying to cover your tracks, you don't need to, and in fact, shouldn't limit yourself to hosts on the target network. Frequent users of the FTP bounce scan better get used to that error message. This vulnerability was widespread in 1997 when Nmap was released, but has largely been fixed. Vulnerable servers are still around, so it is worth trying when all else fails. If bypassing a firewall is your goal, scan the target network for open port 21, or even for any FTP services. If you scan all ports with version detection, then try a bounce scan using each. Nmap will tell you whether the host is vulnerable or not. If you are just trying to cover your tracks, you don't need to and in fact shouldn't limit yourself to hosts on the target network. Before you go scanning random internet addresses for vulnerable FTP servers, consider that sysadmins may not appreciate you abusing their servers in this way. Here you will type command with name and password and then FTP server and victim. Let's remove it and see that how we can perform this scan. Nmap will try to make ICMP echo queries to a target before port scanning it to determine whether the host is alive. Because Nmap won't waste time trying to probe hosts that aren't online, this can save time when scanning many hosts. Since firewalls frequently block ICMP requests, Nmap will also try to connect to ports 80 and 443. which are frequently open on popular web servers, even when ICMP is not. Let's see why we use these features. The first one is -pn, which is more useful to scan. It means don't ping. By default, before Nmap attempts to scan a system for open ports, it will first ping the target to see if it is online. This feature helps save time when scanning, as it causes targets that do not respond to be skipped. Since the selected target does not reply to Nmap's pings, it is not scanned. By using the PN option, Nmap is told to run a complete port scan on the target instead of the standard discovery check. When scanning hosts that are protected from ping probes by a firewall, this is helpful. By specifying the PN option on the same target, Nmap is able to produce a list of open ports on the unpingable system. So, PN is often used in combination with -n option, which disables port scanning. This allows Nmap to perform a script scan without host discovery or a port scan. This SP option is used to perform a simple ping of the specified host. This option is useful when you want to perform a quick search of the target network to see which hosts are online without actually scanning the targets for open ports. When scanning a local network, you can execute Nmap with root privileges for additional ping functionality. When doing this, the SP option will perform an ARP ping and return the MAC addresses of the discovered systems. Let's target our local network. This is our Metasploitable machine IP address. Let's perform TCP synchronize ping. We have different TCP ports, which is open. Let's see TCP acknowledgement ping. The PA option tells Nmap to send TCP acknowledgement packets to the selected hosts. This approach tries to find hosts by responding to non-existent TCP connections in an attempt to elicit a response from the target. It, like other ping variants, can be beneficial when conventional ICMP pings are banned. The PU option performs a UDP ping on the target system. We need as a root user. This discovery approach transmits UPT packets in an attempt to elicit a response from the target. While most firewalled systems will reject this form of connection, certain poorly set up systems may allow it if they are solely set to filter TCP connections. SCTP stand for Stream Control Transmission Protocol, a computer networking protocol that's used to transport messages over the internet. SCTP is designed to be reliable and error-free, and it uses checksums, sequence numbers, and selective retransmission to achieve this. This discovery method attempts to locate hosts using the SCTP. This is typically used on systems for IP-based telephony. ICMP stand for Internet Control Message Protocol. This option initiates a regular ICMP ping to the target to determine whether it responds. This method of discovery works well on local networks, where ICMP packets can be delivered with few limitations. Many Internet hosts are set not to react to ICMP packets for security concerns. ICMP timestamp ping. While most firewalled systems are set to block ICMP echo requests, some misconfigured systems may still respond to ICMP timestamp requests. This makes handy when attempting to ask for responses from firewalled targets. ICMP address mask ping. The PM option performs an ICMP address mask ping. This is unconventional ICMP query similar to timestamp ping. Attempts to ping the specified host using alternative ICMP registers. This type of ping can occasionally sneak past a firewall that is configured to block standard echo requests. An IP protocol ping sends packets with the specified protocol to the target. If no protocols are specified, the default protocols: one is ICMP, second is IGMP, and 4 is IP and IP are used. ARP ping, address resolution protocol ping on the specified target. When scanning the local network, the PR option is implied by default. This type of discovery is far faster than the other ping methods. It is also more accurate because local area network hosts cannot prevent ARP requests, even if they are protected by a firewall. The traceroute parameter can be used to trace the network path to the specified host. The reported information is comparable to the traceroute and tracepath functions found on Unix and Linux systems, with the added benefit that Nmap's tracing is functionally superior to these operations. Force reverse DNS resolution. The ARP parameter instructs Nmap to always perform reverse DNS resolution on the target IP address. By default, Nmap only performs reverse DNS on hosts that appear to be online. The R option is important for performing reconnaissance on a block of IP addresses, since Nmap attempts to resolve the reverse DNS information for each IP address. The reverse DNS information can provide useful information about the target IP address, even if it is offline, or blocking Nmap probes. This R option can dramatically reduce the performance of a scan. Disable reverse DNS resolution. Reverse DNS can significantly frustrate a Nmap scan. Using the N option significantly lowers scanning time, particularly when scanning a large number of hosts. This option is handy if you don't care about the DNS information for the target machine and would rather run a scan that delivers faster results. Alternative DNS. This instructs Nmap to use the host system's DNS resolver instead of its own internal method. This option is rarely used as it is much slower than the default method. It can, however, be useful when troubleshooting DNS problems with Nmap. Remember, the system resolver is always used for IP version 6 scans, as Nmap has not yet fully implemented its own internal IP version 6 resolver. Manually specify DNS server. The DNS servers command is used to manually specify DNS servers to be queried when scanning. Nmap's default behavior is to use the DNS servers specified on your local system for name resolution. This option allows you to provide one or more other DNS servers for Nmap to query. This is handy for computers that do not have DNS installed, or if you wish to prevent scan lookups from showing in the log file of your locally configured DNS server. Create a host list. This scan returns the DNS names for the selected systems. This scan is useful for determining the IP addresses and DNS names of the specified targets without sending any packets to them. Many DNS names can offer useful information about an IP address, such as its purpose or location. Let's see some other advanced feature, which we already discussed about. Here, we will see how and where to use it. Nmap offers a variety of user-selectable scan types. By default, Nmap will run a simple TCP scan on each target system. In rare cases, it may be essential to do more complex TCP or even UDP scans in order to locate unusual services or bypass a firewall. This section covers advanced scan kinds. The TCP SYN scan is the default option for privileged users. The default TCP SYN scan tries to determine the 1,000 most regularly used TCP ports by sending a SYN packet to the target and waiting for a response. This form of scan is referred to as stealthy because it does not seek to establish a full connection with the remote server. This stops many systems from registering a connection attempt during your scan. You must log in with root or administrator privileges. So, this SS options perform TCP SYN scan. Remember, stealth operation is not guaranteed. Modern packet capture programs and advanced firewalls are now able to detect TCP SYN scans. This scan is the default scan type for non-privileged users. It is also used when scanning IP version 6 targets. The TCP Connect scan is a simple probe that attempts to directly connect to the remote system without using any stealth. This give me same result as you see before because I'm using this commands on same IP. I just show you how to use it as a beginners. It will help you. UDP scan. TCP is the most widely used protocol. Many network services, such as DNS, DHCP, and SNMP, still use UDP. When running a network audit, make sure to check for both TCP and UDP services to gain a more full picture of the target host or network. We will use SU option to perform a UDP scan. It takes time to perform this scan. TCP null scan. We will use SN option to perform a TCP null scan. TCP null scan. We will use SN option to perform a TCP null scan. TCP null scan instructs Nmap to send packets with no TCP flags enabled. This is accomplished by changing the packet header to 0. Sending null packets to a destination is a way to deceive a firewalled system into producing a response. TCP fin scan. When Nmap sends packets in an attempt to request a TCP ACK from the selected target system, it activates the TCP FIN bit. This is another method of sending unexpected packets to a target in an attempt to extract information from a firewall-protected system. XMOS scan, also known as a Christmas tree scan, it's used to identify the presence of a firewall, determine the state of ports, scan through stateless firewalls, and access control list filters and detect closed ports. XMOS scans are popular because they are fast and similar to out-of-state FIN and ACK packets. However, modern devices can log XMOS scans and other scans, so they are not as stealthy as they once were. TCP ACK scan. To detect whether the target system is protected by a firewall, use the SA option. When doing a TCP ACK scan, Nmap will probe a target and check for REST replies. If no response is received, the system is assumed to be filtered. If the system does return a REST packet, it is identified as unfiltered. Ports are designated as filtered, indicating that the system is likely secured by a firewall. The 6 unfiltered ports listed are likely to have unique rules in the target firewall that allow them to be opened or closed. Custom TCP scan. The Scan Flags option is used to perform a custom TCP scan. The Scan Flags option enables users to specify a custom scan using one or more TCP header flags. The Scan Flags option allows you to use any combination of the flags specified in the table below. For example, Nmap Scan Flags and SYN Urgent with no space activates the SYN and Urgent TCP flags. IP Protocol Scan. The IP Protocol scan displays the IP protocols supported by the target machine. The most common protocols on modern networks are ICMP, TCP, and UDP. This option is useful for quickly determining what types of scans to execute on the selected target system, depending on its supported protocols. Send raw Ethernet packets. When you use this option, Nmap will bypass your system's IP layer and broadcast raw Ethernet packets across the data connection layer instead. This can be used to resolve issues with your system's IP stack. Send IP packets. Enabling this option forces Nmap to scan using the local system's IP stack, instead of generating raw Ethernet packets. Let's move on to port scanning. There are 1,31,070 TCP IP ports and 65,535 TCP ports, and the same UDP ports. By default, Nmap searches only the 1,000 most often used ports. This is done to reduce time when scanning several targets, as most ports outside of the top 1,000 are rarely used. However, you may wish to check outside of the default range of ports to seek for unusual services or ports that have been forwarded to another place. Here we will describe the options that enable this and other port-specific capabilities. This F option instructs Nmap to perform a scan of only the 100 most commonly used ports. Nmap defaults to scanning the top 1,000 most regularly used ports. This option reduces the number to 100. This can significantly speed up scanning while still covering the vast majority of widely used ports. Scan specific ports. The P option is used to instruct Nmap to scan the specified port. Let's see here how we can search about specific port. Here, I want to search about port number 80. Is it open or closed? And also, you can search some multiple ports. And also, you can search range of ports. This is the result Nmap give us. If you cannot remember port's number, then you can search ports by specified their name. Let me show you in this example. Scan ports by protocol. Specifying a T or U prefix with the P option allows you to search for a specific port and protocol combination. Using this syntax instructs Nmap to perform a UDP scan on port 53 and a TCP scan on port 25. By default, Nmap will only scan TCP ports. In order to scan both TCP and UDP ports, you will need to enable additional scan types. Scan all ports. The P option with asterisk sign option is a wildcard used to scan all TCP IP ports on the specified target. You must enclose the wildcard statement in quotes, so your system does not interpret it as a shell wildcard. Scan top ports. The top ports option is used to scan the specified number of top-ranked ports. By default, Nmap scans the 1,000 most regularly used ports. Using this option, you can scan any number of top-ranked ports you want to scan. Perform a sequential port scan. Nmap's default scanning technique generates a random port scan order. This is handy for getting around firewalls and intrusion protection systems. The R argument overrides this functionality, instructing Nmap to look for open ports in numerical order. One of Nmap's most impressive and valuable capabilities is its ability to detect operating systems and services on remote systems. This feature examines replies from scanned targets and attempts to determine the host's operating system and installed services. TCP/IP fingerprinting is the method of identifying a target's operating system and software versions. Although it is not a precise science, Nmap developers have taken considerable care to ensure that TCP/IP fingerprinting is accurate and dependable. And like the majority of Nmap's features, version detection can be adjusted by an array of arguments, which are discussed in this section. Nmap is, in most cases, able to identify the operating system on a remote target. Operating system detection is performed by analyzing responses from the target for a set of predictable characteristics which can be used to identify the type of operating system on the remote system. Attempt to guess an unknown operating system. If Nmap is unable to accurately identify the operating system, you can force it to guess by using this option. Service version detection. The SV option will attempt to identify the vendor and software version for any open ports it detects. The results of this scan show the software vendor and version number for services that Nmap was successfully able to identify. The version detection system built into Nmap was designed to efficiently recognize the vast majority of protocols with a simple probe and pattern matching syntax. Some protocols require more complex communication than version detection can handle. Let's perform RPC scan. RPC mean remote procedure call. This option scan on the specified target. This is most commonly associated with Unix and Linux systems, specifically for the network file system service. Troubleshooting version scans. This option can be enabled to display verbose version scan activity. This version trace option can be helpful for debugging problems or to gain additional information about the target system. Many Nmap features offer customizable timing options. These time settings can be utilized to accelerate or slow scanning activities, depending on your requirements. When scanning a large number of hosts on a fast network, consider increasing the number of simultaneous operations to achieve faster results. Alternatively, while scanning slow networks or the internet, you may want to slow down the scan to obtain more accurate results or avoid intrusion detection systems. This section goes over the options for different timing features. Nmap timing parameters are accepted as milliseconds by default. You can also specify timing parameters in seconds, minutes, or hours by appending a qualifier to the time argument. In this table, you can see examples of time parameter usage syntax. Timing templates are handy shortcuts for various timing options. There are 6 templates, from 0 to 5, that can be used to speed up scanning for faster results or to slow down scanning to evade firewalls. You can see timing template in this table. Let's check our target machine IP, and then we will use timing template commands. The T parameter is used to specify a timing template for an Nmap scan. First, we will see T0. We can call it paranoid scan, which is extremely slow. So, this is the most conservative template. It transmits probes one by one, with an extensive delay between them. This is time taken, so I close this for now. And see T4, which is call aggressive scan. You can see fast result of this scan. Let's see insane scan, which is very fast and aggressive scan. You can see in this list that name of the first scan is paranoid, which is extremely slow. T1 name, sneaky, which is useful for avoiding intrusion detection system. If there is any firewall or detection software, you can use this. Remember, this may be also time taken. T2, polite scan, which is unlikely to interfere with target system. This is relatively faster than the sneaky scan, but still relatively stealthy. It delivers probes in smaller groups. This timing pattern is the default, and it strikes an ideal mix between speed and stealth. It sends probes in larger groups, each with a delay between them. This template is suitable for the vast majority of scanning applications. T4. This aggressive scan setting allows for faster scanning. It transmits probes in larger groups, each with a shorter latency. This template is useful for quickly scanning a large number of hosts or ports, but it is more likely to produce incorrect results or be detected by the target host. T5. The insane scan. This is the quickest timing template. Using this template is strongly discouraged because it is highly likely to cause significant problems for the target host. It's also possible that the target firewall will block your IP address. This scan will certainly produce numerous alarms on the target. However, it sends probes as quickly as possible, with no inter-probe latency. This template is useful for checking multiple hosts or ports quickly. Time to live, purpose of use, to modifying the TTL, can help in situations where you want to limit the scan to a specific network, hop, distance, potentially bypassing firewalls or identifying closer network devices. If not specified the TTL number, the Nmap uses the default TTL value set by your operating system. This TTL value can be set between 0 and 255. Let's see another timing option: minimum number of parallel operations. This option is used to specify the minimum number of parallel port scan operations Nmap should perform at any given time. Nmap automatically adjusts parallel scanning options based on network conditions. In some rare cases, you may want to specify custom settings. While manually setting the min parallelism option may increase scan performance, setting it too high may produce inaccurate results. Maximum number of parallel operations. This option controls how many parallel port scan operations Nmap will be performing at any given time. Minimum host group size. This option is used to specify the minimum number of targets Nmap should scan in parallel. Nmap will run scans in parallel to save time when scanning many targets, such as a range or a subnet. By default, Nmap adjusts the size of host groups based on the type of scan and network conditions. When this option is used, Nmap will try to keep group sizes above the specified limit. Maximum host group size. This option allows you to set the maximum number of targets Nmap should scan in parallel. This option specifies the maximum number of hosts in a group. This setting is useful for reducing network strain or avoiding red flags with many network security solutions. Maximum RTT timeout. This option is used to specify the maximum round-trip timeout for a packet response. Nmap automatically modifies RTT timeout options for the best performance by default. The default maximum RTT timeout is 10 seconds. Manually decreasing the maximum RTT timeout will result in speedier scan times, particularly when scanning big blocks of addresses. Setting a high maximum RTT timeout. This option controls the initial RTT timeout value used by Nmap. These flags specifies the initial amount of time Nmap will wait for a response from a target host before sending a retransmission probe, essentially controlling how quickly Nmap starts to assume a host is not responding and moves on to the next probe. A lower value speeds up the scan, while a higher value can improve accuracy by allowing more time for a response from slower networks. Maximum retries. By default, Nmap adjusts the number of probe retransmissions dependent on network circumstances. This maximum retries option can be used to change the default settings or troubleshoot connectivity issues. Specifying a high number may lengthen the time it takes for a scan to finish, but it will yield more accurate findings. Lowering the maximum retries option will speed up a scan, but you may not get accurate findings if Nmap gives up too soon. Host timeout. A host may take a long time to scan if it is located on a slow or unreliable network. Systems that are protected by rate-limiting firewalls may also take a considerable amount of time to scan. This option instructs Nmap to give up on the target system if it fails to complete after the specified time interval. Nmap scans many targets simultaneously. If one host takes a long time to react, Nmap will most likely scan other hosts during that time. This decreases the possible bottlenecks that slow hosts can cause. So, the next options is minimum scan delay. Some systems use rate restriction, which can impede Nmap scan attempts. When rate limiting is identified, Nmap will automatically adapt the scan delay. If rate limitation or intrusion detection systems are in use, you may find it handy to specify your own scan delay. In the preceding example, the scan delay of 6 seconds directs Nmap to wait 5 seconds between probes. This scan is time taken, so I close it. The next option is maximum scan delay. This option also may be time taken, so I skip the process duration. Here just show you a result. Nmap automatically adapts the scan delay to account for network conditions and/or rate-limited hosts. To set a maximum time between probes, use this option. This can speed up a scan, but at the sacrifice of accuracy and increased network stress. Minimum packet rate. By default, Nmap will modify the packet rate during a scan based on network conditions. In some circumstances, you may want to set your own minimum rate, but this is generally not suggested. In this example, minimum rate 30 asks Nmap to deliver at least 30 packets per second. Nmap will use this value as a low threshold, but it may scan quicker if network conditions allow. So be careful, to setting the minimum rate too high may reduce the accuracy of a scan. Maximum packet rate. This option is used to specify the maximum number of packets Nmap should send per second. In the example, using maximum rate 30 instructs Nmap to send no more than 30 packets per second. This can significantly slow down a scan. However, it can be useful when trying to bypass intrusion detection systems or targets that use rate limitation. Defeat reset rate limits. The defeat reset rate limit option can be useful if you want to speed up scans on targets that implement RST packet rate limits. It can, however, lead to inaccurate results, and as such it is rarely used. This option is rarely used because, in most cases, Nmap will automatically detect rate-limiting hosts and adjust itself accordingly. Let's move on to another section, which is evading firewall. Firewalls and intrusion prevention systems are intended to prevent tools, such as Nmap, from providing an accurate image of the systems they protect. Nmap contains a number of features aimed at circumventing these barriers. This section describes the many evasion tactics included in Nmap. Let's understand firewall. What is firewall? A firewall is like a gatekeeper for your network, deciding which data packets can pass through. It follows rules to either allow or block traffic. A basic firewall checks the IP and transport layer headers of packets. A more advanced one might also look at the actual data being transmitted. IDS, mean Intrusion Detection System, monitors network packets for suspicious patterns or content and sends out notifications if it finds anything dangerous. An IDS inspects not only the IP and transport layer headers, but also the data in the transport layer for malicious patterns. To evade detection by a typical firewall or IDS, consider dividing up your Nmap activity into smaller chunks. Nmap has an F option to fragment packets, which splits IP data into smaller bits. Fragmentation splits the data into smaller parts, making it harder for the firewall or IDS to detect. The IP header contains fields like identification and fragment offset to help reassemble the data on the receiving end. MTU option is similar to the fragments option, except it allows you to specify your MTU to be used during scanning. This creates fragmented packets that can potentially confuse some firewalls. We will see these packet fragmentation in Wireshark course. Wireshark is the best tool when we analyze the packets. In this example, the MTU8 argument instructs Nmap to use tiny 8-byte packets for the scan. The MTU must be a multiple of 8, for example 8, 16, 24, 32, etc. Use a decoy. In Nmap, a decoy scan is a technique used to conceal the true source of a port scan by introducing additional IP addresses that appear to be scanning the target alongside the actual scanning host. The purpose of a decoy scan is to confuse network defenders and make it more difficult for them to identify the true origin of the scan. In this example, Nmap-D and random10 instructs Nmap to generate 10 random decoys. You can also specify decoy addresses manually used like this. Remember, using too many decoys can cause network congestion and reduce the effectiveness of a scan. Additionally, some internet service providers may filter spoof traffic, which will reduce the effectiveness of using decoys to cloak your scanning activity. Idle Zombie Scan. The idle zombie scan is a unique scanning approach that exploits an idle system and uses it to scan a target system for you. The scan takes use of some systems' predictable IP sequence ID generation. To be successful, an idle scan must be performed while the zombie system is genuinely idle. To perform idle scan, we need a zombie computer on the network which has incremental IP ID sequencing. For that purpose, we will use Nmap scripts. If you try any random IP, it will give you error, like here I'm showing you. This is the command for idle scan. Here I'm using any random IP as a zombie IP. And this is my Kali Linux IP address. If you face like this problem, then you should follow these steps. Remember these 3 steps for idle scan. Number 1. Root privileges on the source system. I mean, you must use sudo option. Number 2. You have idle zombie system IP address. And number 3. Port number 80 must be open on the zombie system. Let's use Nmap script. In this directory, we will see a specific file. With name of IP, ID sequence. Let's use this file. We will scan complete network subnet to find zombie computer. For simple scan, I just use top 2 ports. Did you notice? I didn't use sudo command. It means that Nmap will not give me a proper result. The purpose of showing you each step, if you face any problem, then you can solve it yourself. Let's use a sudo command for a root user. Now, you can see a different result. If you performed scan without root user, you couldn't find these line. This is the previous result, where I was not be able to see a proper result. We can use this computer as a zombie, because of IP ID incremental. If it doesn't work, then we will use another IP. So this is our zombie computer. Let's use it. So here I use a zombie IP. And the second one is my source IP. Here you can see the whole process of scanning has been capturing by Wireshark. Here you can see the source addresses and destination addresses. Scanning process has done. Let me stop Wireshark. So basically, I told to Nmap perform your scan, but hide my IP, instead show a fake IP. You can see, this is my Kali Linux IP. But in result you can't see my IP address, but instead you see a fake IP address, or zombie IP. And this is our target IP address. So here, we successfully scan our target IP through zombie machine. Manually specify source ports, scan. Every TCP segment includes both a source and a destination port number. By default, Nmap probes a target using an available outgoing source port at random. This option causes Nmap to utilize the specified port as the source for all packets. This technique can be used to exploit flaws in firewalls that are incorrectly configured to accept all incoming traffic based on a specified port number. This process little bit time taken, so wait for it until the process done. Append random data. Nmap sends packets that are typically a certain size. Some firewall suppliers know to search for predictable packet sizes. So, this option adds the specified amount of extra data to probes in an attempt to avoid these types of tests. In this example, all packets delivered to the target receive an additional 25 bytes. Randomize target scan order. This option helps firewalls and intrusion detection systems to avoid detecting multiple target scans. This is achieved by reading them in random order rather than sequentially. Spoof MAC address. Here, Nmap is asked to generate a randomly generated MAC address. This makes your scanning activity more difficult to trace by preventing your MAC address from being recorded on the target system. The spoof MAC option can be controlled by the three parameters. Number 1 generates a random MAC address with the help of 0. And the second argument, we can specify you want. Here, I'm giving a simple address, as you can see. You can check here, my spoofed MAC address. And with the help of third argument, you can spoof a MAC address is by giving any vendor name, like Dell, Apple, or 3Com. But here I'm using Dell. This is how you can spoof MAC address with Nmap. Send bad checksums. The TCP/IP protocol relies on checksums to ensure data integrity. Crafting packets with incorrect checksums can, on rare instances, result in a response from a badly designed machine. In this example, we received no results, indicating that the target system is correctly set up. This is a usual outcome of using this badsum option. Only a poorly configured system would respond to a packet with a bad checksum. Nevertheless, it is a good tool to use when auditing network security or attempting to evade firewalls. Let's see what we have an output option, why, and how to use it. Nmap has numerous methods for generating structured output. In addition to showing the conventional output on the screen, you can save scan findings to a text file, XML file, or a single-line greppable file. This functionality is useful for scanning a large number of computers or comparing the results of two scans using the NDiff tool. As you can see, in this picture, we have different type options. We will discuss one by one. If you want to save a result in a simple text file, you can use this option. Let's first check my username. We have these files, and we are going to save our result file here. We are scanning our Metasploit machine and save our result in a text file. Let's check again, is there any file we add here? Here we go, this is our scan file in a text format. Let's open this file in a terminal. Very nice, our result is here. Now you can share this file with anyone you want. Save output result to XML file. First of all, let's clear the extra files. If some file's not removed, just read the error and fix it. Let's use another tab to show you clearly. Here, let's save our scanning result in XML file. Let's check a file and open it. The generated XML file contains hard-coded file paths that can only be used on the system in which the file was created. Greppable output. The scan will be saved in scan.txt file, which can be useful when combined with text parsing tools like Perl or grep. In this example, the grep utility will display all instances of the specified text found in the scan.txt file. This makes it simple to quickly search for specific information when analyzing results from a large scan. We have another useful option, which is output all supported file types. The OA parameter saves the output of a scan in a 3 different format. Here we saved our scan result in scan files. Let's check our files. Is there any files we saved? Now, here we saved our scan result files in 3 different formats. The first one is scan.gnmap is a greppable output file. The second one is scan.nmap, which is a plain text output file. And the third one is scan.xml, which is a XML output file. Display scan statistics. This option can be used to periodically display the status of the current scan. On slower scans, you may become bored looking at your screen doing nothing for extended periods of time. This option can help with this issue. In the preceding example, this 4-second option instructs Nmap to display the status of the current scan every 5 seconds. This option enables script kiddie output. I'm saving scan result in stylish font file. Script kiddie output is like interactive output. This option is included as a joke and isn't really useful for anything other than a good laugh. Here you can see, font style has been changed. Let's see another section, which is related to troubleshooting and debugging. Technical issues are an unavoidable feature of using computers. Nmap is no exception. Occasionally, a scan may not deliver the expected results. You can get an error or no output at all. Nmap provides numerous options for tracing and debugging a scan, which can assist determine why this occurs. In this section goes over these troubleshooting and debugging tools in detail. If you want to understand about Nmap, you can use this command to get help in Nmap, so you can execute Nmap in a terminal without using any parameters. You can also use the -h switch to print a help summary page. For more detailed information, you can read the Nmap manual page by typing man nmap on the command line. Scroll below, you can get more and more information which can help you to understand Nmap. Let's display Nmap version and why we check it. When troubleshooting Nmap difficulties, always ensure that you have the most recent version installed. Open source tools such as Nmap are rapidly developed, and defects are usually resolved as soon as they are discovered to ensure that you are using the most recent version. Compare your installed version to the one accessible on the Nmap official website. This ensures that you have access to both the most recent features and the most bug-free version accessible. Verbose output. When we use just Nmap with -v only, it means we are checking version. But when we increase any website or address, it means we want verbose output. What is verbose output option and why we use it? Nmap prints many extra informational notes. When in verbose mode, for example, it prints out the time when each port scan is started along with the number of hosts and ports scanned. It later prints out a concluding line disclosing how long the scan took and briefly summarizing the results. Here is my Metasploitable machine address. Here, "V" increase the verbosity level. Using verbose mode in Nmap will cause it to print more information about the scan, including open ports as they are found. Completion time estimates when the scan is expected to take more than a few minutes, and additional host information such as TCP and IP, ID, sequence number values. If you want to increase the verbosity level even more, you can use this. Or you can use like this with V. Result will be the same. Debugging option. This D option, use for debugging. This is target IP address. Here we have timing report and list of discovered open ports. Also, we have round-trip time variance. Network communication can be very unpredictable, and Nmap compensates for this uncertainty by creating a range of timeout values. Nmap dynamically adjusts RTT timeout options for best results by default. So, the default maximum RTT timeout is 10 seconds. Certain scan options such as UDP scanning and version detection can increase scan times substantially. This SRTT option smoothed the round-trip time. This estimate of response time is based on the observed traffic between the Nmap station and the remote device. This value is provided in microseconds. Display port state reason codes. To view the reason for a port state in Nmap, use the reason flag in your scan command. This will display detailed information about why a port is classified as open, closed, filtered, or unfiltered, essentially providing the reasoning behind its state based on the network response Nmap received when probing the port. Information in this field can be useful when trying to determine why a target's ports are in a particular state. Ports that respond with SYN or ACK are considered to be open. Ports that respond with connection refused or reset are typically closed. Ports that do not respond at all are generally filtered by a firewall. Only display open ports. The open argument excludes closed and filtered ports from the scan results. This option is useful when you wish to simplify the scan results by just displaying open ports. This was my Metasploitable machine. Let's scan a website. As you can see, we have just open ports. Let's scan this website without open option. And the result, you can see here, open and closed ports. You can use these options as you want. This was our open port scan result, and below is without open option. Trace packets. This packet trace parameter instructs Nmap to display a summary of all packets sent and received. The packet trace option causes Nmap to print a summary of every packet it sends and receives. This can be extremely useful for debugging or understanding Nmap's behavior. This is Metasploitable machine IP address with port numbers. It can be useful for diagnosing connectivity problems. In this example, shows extensive information on each packet transmitted to and received from the target system. Don't worry, we will look on packet trace in Wireshark course with detail. Here you can only see ports on a target with machine with connection information. Display host networking configuration. The iflist option displays the network interfaces and routes configured on the local system. It shows the overall network and routing information for the local system. This option might help you rapidly detect network information or fix connectivity issues. Specify which network interface to use. This E option is used to manually specify which network interface Nmap should use. Many systems include several network interfaces. Most current laptops, for example, include both a standard Ethernet port and a wireless card. To ensure that Nmap uses your preferred interface, use the E flag on the command line. In this case, E instructs Nmap to scan via the ETH0 interface on the multi-homed host system.